Assalamualaikum and hi. My name Muhammad Fareezman bin Zamzuri. My metric number F18B0066. I'm an animal husbandry student. My research center is about the technology improvement of the smart artificial incubator system in aquaculture for tilapia eggs. Okay, this is a list of content in my slide. Now we go to the research background of these projects. The fishery sector has been a significant source of the animal protein for Malaysian population. In 2017, the country overall fishery output 1.7 million ton, which nearly 1.5 million ton from capture and 0.2 million ton come from aquaculture industry. In 2015, the global tilapia production reached 6.7 million ton, which a market value of USD is 9.8 billion from FAO 2070. The China and Indonesia are the main producers of the Oreochromis niloticus. For the problem statement of this project have two. The first is having problems in lab story for researchers, and the second is about have problems which low rate of egg hatching and survival rate of fry. Now we go to the objective part. The first objective is to determine the survival rate of fry and hatching egg of Oreochromis niloticus using the smart artificial incubator. And for the second is to determine the smart artificial incubator technology that can be used in the aquaculture laboratory or not. Hypothesis. For the null hypothesis is improve the technology of smart artificial incubator does not give any positive impact to the tilapia fry, and for the alternate hypothesis is improve the technologies of smart artificial incubator system promotes tilapia fry which improve and better the qualities. Now we go to the literature review parts. The history of aquaculture. Aquaculture is a farming species in an aquatic environment which includes catching fish, mollusks and aquatic plant in new marine or brackish water. Aquaculture has been practiced since 4,000 to 5,000 years ago in ancient China and Egypt. The next point is the species of tilapia also including Oreochromis niloticus, Oreochromis uranus, and various red hybrid of the former two species and Malaysian were first introduced to the Mozambique tilapia or Oreochromis mozambicus during World War II. This is a taxonomy of the Oreochromis niloticus. Now we go to the water parameter. Water quality for aquaculturists refers to the quality of water that enables successful for the propagation of the desired organisms. This parameter provide important information about the health of a water bath. The water parameters such as dissolved oxygen, pH and water temperature. And the best water temperature for the reproduction is above 26.7 Celsius and it does not happen below 20 Celsius. For the pH is 6.5 to 9.0 is suitable for aquaculture. The optimal pH for tilapia between 7 to 8, but tilapia can survive in pH ranging from 5 to 8. Last is about the dissolved oxygen. Tilapia are able to tolerate dissolved oxygen level less than 0.3 mg per liter, a level that would prove better to most or other farm fish. Artificial incubator. What is artificial incubator? Incubator is a device simulating fish incubation by keeping eggs in a good water flow rate, mixing the egg with a balanced dissolved oxygen and oxygen flow in a good condition and hatching the egg in artificial ways. Okay, using the artificial incubator also to ensure the healthy survival It's necessary to take proper care of the egg by putting them in a suitable incubator. Artificial incubation and hatching of fish embryos simulate this natural process. In the wild, eggs or egg males are susceptible to predation and are easily damaged by the continual change of the natural environment. Now we go to the part of the methodology. This is my picture of my smart artificial incubator which will be designed. This technology for tilapia egg will be designed use a plastic tray with a length of 80 cm, a width of 50 cm and a height of 15 cm. From a width of 80 cm, the 13 cm will be used to make a water filtration place for this system before being repumped for use, because this system use a recycle water system. For the water filtration part, a sponge is used as a filter device to filter the dirty before it is repumped through the piping system. The type of pipe that will be used is a PVC pipe. In this system, a total of 3 jars will be placed after the calculation of the size the jar which the tray is done. For the water flow in artificial incubator, in this incubator, water flow is from the bottom of the container through the flow can be adjusted to the suspend the egg from the mass in continuous motion in the water column. Okay. The type plastic jar which a volume of 1.5 liter and perforate plastic incubation tray we will use size 70 cm times 25 cm. In addition, the pump is used an aquarium pump that is Sobo brand, which model WP205K, that's frequency 50/60 Hz and 5 watts of power. This technology will take 4 weeks to create and fully functional to be a test with tilapia fish eggs. This technology will be produced with a small size compared to the real size the artificial incubator system that used in the hatchery or house for the incubator system. The technology will be used will be also be designed so that it can be used in laboratories for study involving fish egg and incubator system with the appropriate size of technology for laboratory use. Okay, artificial incubator trial. For the artificial incubator, the total of 6,000 eggs of tilapia with species Orechromyliticus will be used. Each group will have a 3 jar and will be labeled with A, B, C, where each jar will be filled with 1,000 eggs. The artificial incubator trial will be carried out in the aquaculture laboratory, University Malaysia Kelantan Jelly Campus. The egg will be divided into the 2 groups, which consists of the 1 treatment. This is a smart artificial incubator, and 1 control group. This is a real artificial incubator system in a hatchery. Okay, next, fish egg will be put in each jar at 8 am after the process of collecting eggs from the mouths of the female fish. The eggs in the jar will be monitored 2 times a day at 8:30 am and 5 pm until they reach fry stage of the 11 days of age. This is the important part where data will be collected as a result. This technology. This is a part egg hatching rate and survival rate of fry. Now we go to the egg hatching sampling. Egg in the incubation system will be monitored 2 times a day at the times 8:30 am and 5 pm. This sampling will take 4 days because the egg hatching for tilapia will take 48 hours to 66 hours or 2 to 4 days to complete the hatching. During this process, if there are any damaged eggs, they will be removed and the number of egg released will be recorded in the data. For the result, the egg hatching rate will be calculated on the 4th day, which is after the last monitor is done. Then the percentage of hatching rate will be calculated for each jar. Now we go to the second data that will be collected to determine the survival rate of fry. For the sampling, it will be start and recorded on the 5th day after the complete hatching rate process take place for the 4 days. This sampling will be run and will be recorded for the 7th day. During the process, it will be monitored 2 times a day at 8:30 a.m. and 5 p.m. During the monitoring and dead larvae, it will be removed and the number of the dead larvae will be recorded in the data. The percentage of the survival rate of fry will be calculated on the 7th day during the last time monitor data was taken. Now we go to the other parameter. This part is very important because it can give the effect of the egg hatching and the survival rate. During the sampling process, the water parameter, namely water temperature, pH and diesel oxygen, will be checked in the incubator system by using the multi-parameter to ensure is that the correct level and does not affect the project. Water parameter will be monitored 2 times a day at 8:30 a.m. and 5 p.m. Okay, for the data analysis, data will be analyzed by usage of one-way ANOVA test and which uses of IBM SPSS statistics. Data calculation based on the percentage of hatching eggs and survival rate of fry for tilapia. Duncan multiple range test will be used in order to compare the data collected and analyzed at the 65% confidence level. Difference were considered important. Both of the means were provided with a standard error. Now we go to the expected outcome. The expected outcome from this research based on the technology improvement in smart artificial incubator for aquaculture that produce a high survival rate and high hatching rate for tilapia, which species Orochromys. The next point, this technology can be give benefit to aquaculture sector, especially tilapia industry, breeder and government. For tilapia breeder, this technology can improve the survival rate and hatching eggs, so the breeders can increase the production of tilapia seeds and can meet the demand of farmer who want to buy the tilapia seeds for the growth out process. For the lastly is the government also have a benefit from this technology because which a large amount of tilapia is produced and annual statistic can be recorded and positive result can be obtained because breeder tilapia production is high. Gantt chart. This is the way the work is done according to the step by step that has been arranged to complete the final year project, and this project will be run for 12 months, which start in February 2021 and ended in January 2022. This is a flowchart for my project. The reference, and that's all from